Hello engineers, welcome to second part of the UG 29, that is stiffening calculation under external pressure. In last lecture I asked you which type of stiffening is best and how to choose which stiffening is suitable for our pressure vessel. Today we will see which stiffening is best for our design. Okay, why we are choosing this stiffening, guys? Because we need to provide extra strength, right? So to provide extra strength to our vessel, so generally we are considering the stiffener. Okay, so based on the strength only, we are selecting the different types or shapes of the stiffener. Which shape have highest strength? So that shape will be considered as a stiffener for our design, guys. So strength related to what, guys? Moment of inertia of an object. This moment of inertia of an object decides the strength of the stiffener. So moment of inertia means what? It is a measure of body resistance to angular acceleration. So which is equal to product of mass of the body and the square of its distance from the axis of rotation. So for different shapes, different moment of inertia are there. So that will decide the which shape is optimum choice for our design. So for example, in last lecture we see bar type stiffener, T type stiffener, angle type stiffener, and I type stiffener, right? So today we will calculate moment of inertia for that, some of the shapes of the stiffeners, guys. So first we will calculate the moment of inertia for bar type stiffener. So this is our vessel. So last point. So this is our vessel, right? So this is the thickness of the vessel. So, and this is our bar type stiffener. So, this is the height of the bar type stiffener, and this is the thickness of the bar type stiffener. So, this is the neutral axis, guys. I hope you are understanding. So, if you see this, it is looking like a rectangular section. So, we know that for rectangular section, the moment of inertia is BD cube by 12. So, here I write the same thing. So, the moment of inertia for this bar type stiffener ring is equal to T H cube by 12. Okay, so section. By seeing this formula, you can say that the moment of inertia is based on the cube of the width of the cross section, guys. So, depending upon the orientation, also this moment of inertia will decide the strength of the stiffener. So, you need to consider how I'm placing the stiffener, in which orientation I'm placing the stiffener. So, that will also create a major change in our design, guys. So, let's calculate moment of inertia for T-type stiffener, guys. So, this is our shell. This is our shell. Okay, this is the T-type. So in engineering, we know that. So for T-type section, we calculated the moment of inertia, right? So by cutting like this, for dividing the two sections. So I'm dividing the T shape into two sections. This is the second one. This is the first one. So I'm considering this is one and this is two. Okay. So for first one, this is my T1 and H, and this is T2 and W. So and next this is Y. So which is distance from bottom to center of the first one, and this is Y2. So which is from bottom to center of the second part. Okay. So first calculate area of the cross section. So A1 is equal to, so it is looking like rectangular section, right? So length into breadth is our area. So T1 into H is our area of the first part, and the T2 into W is our area of the second part. Okay, now let's try to find out the Y1, guys. So Y1 is equal to H by 2 for Y2. So we know that up to here it is H. So it is half of the T2, right? So T2 by 2 plus H. So this is all general things, guys, which already studied in engineering classes. So I'm just recalling it. Okay. So for finding the moment of inertia, I'm just recalling it. So let's try to find out uh, moment of inertia for each section, guys. This is I1. Let's say this is I1 and this is I2. So I will find out moment of inertia for different. So I1 is equal to T1 H cube by 12. So same like this. So I2 is equal to W into T cube, T2 cube by 12. So this is how we need to calculate I1 and I2 for this T section. And we required centroid. We need to calculate centroid also, because finally we need to find out combined moment of inertia, guys. So that's why I'm calculating this centroid. So centroid is equal to A1 Y1 plus A2 Y2 by A1 plus A2. So this is the general formula. So if you don't know, just recall your engineering basics. So you will learn. Okay, I hope you understand. So if you add these two, you will get summation of an I2, and I2 gives the total moment of inertia. So then we need to calculate combined moment of inertia. So our final agenda is to calculate combined moment of inertia. So combined moment of inertia is equal to summation of an yn whole square plus summation of I minus c into summation of an into yn. So this is our available a combined moment of inertia or available moment of inertia. So if you put values in first one and this one, so you will get higher moment of inertia for this T type, guys. Okay. because you are here seeing that by seeing the cross section also you can say. So it is having a high moment of inertia. If you calculate moment of inertia for I type, so it will give more moment of inertia. So more moment of inertia means more strength. So more strength means it will give less thickness and less dimensions, right? So then your weight of your wedge also decreases. Okay. So finally, we preferred the section which gives high moment of inertia as a stiffener ring, guys. But generally, in practical cases, most of the industries preferred I section. I section and L type. This is also called as angle section. So I type and L sections are generally used. So in some cases C sections also used, guys. In some cases C section also. Depending upon the weight of the vessel and volume of the vessel, we prefer this, guys. There is not necessary to use every time we will use I type only because of higher moment of inertia. So it is not like that. So according to volume, according to weight of your vessel, you need to select which is suitable for your vessel, guys. Okay. So I hope you are getting my point. If you like the contents, please subscribe, guys. Please subscribe. Please hit the like button and share to your friends also. So they will also get benefited. And for this video, the value for this video and the important for this video is that, right? So it need to reach most of the persons. Then only it will have some use, right? So otherwise there is no use of uploading this content in the YouTube channel. So I am requesting you to please share to your colleagues. So please suggest this channel to your colleagues also if you really like my content. So as of now, we calculated the available moment of inertia only. So as of now, we are calculated available moment of inertia only. But code given some formulas to find out required moment of inertia. So we need to compare this available moment of inertia with code given formula, guys. Okay.